What's up, Room 10? Hey, it's science time. Let's go ahead and get out those science books and let's open up to page 118. Hey, it looks so far like you guys are figuring out how to get in there and type in your vocab and definitions into the Google Classroom. That's awesome. Go ahead, keep doing that. Make sure, type out the answers for the quick check. Yeah, almost forgot there for a second. So make sure you're getting those vocab words, definitions. Notice I put the vocab words in there for you. I even gave you a little step. All you had to do is type out those definitions. So make sure you get that done, and then don't forget to click turn in. It's in like the right hand corner up here on your screen in the Google Classroom. You hit turn in, and then it says, are you sure you want to turn it in? And then you click it again, turn in, and then it will show that you've submitted it. That way I can go in there and check, make sure you guys are doing it all. And that way you don't have to like turn in papers to the school or do any of that kind of stuff. You can just submit it that way. That's the way we're going to be doing our science homework for, I don't know, I guess the rest of the year. Whenever there's vocab, definitions, stuff like that, it's going to be in the Google Classroom. Same thing for science quizzes or any more tests that we're going to have. They're also going to be in the classroom. Sweet. We're on page 118. If you haven't gotten there yet, go ahead and get there. I'm going to go ahead and tell you some of our objectives for today. A couple of our objectives, our goals are to learn about a front, what an air front is, cold front, warm front, stationary front. We're going to talk about all those. And then we're going to talk a little bit about global winds. Now, global winds are exactly what they sound like. They're winds that go around the globe. In case you don't know what the globe is, that's the Earth. All right, sweet. Cool. Here we go. Page 118, up at the top, fronts. Follow along with me. You should have your books out. Now, when two unlike air masses meet, the boundary between the masses is called a front. Now, remember yesterday we talked about cool air masses and warm air masses. So when those two air masses meet, or maybe even it's two cold air masses, when those guys meet, that is a front where they crash into each other. Now, a cool air mass may push itself under a weaker warm air mass. This type of front is called a cold front. It often brings rainy weather that may include thunderstorms and hail and cold. Yeah. A cold front usually moves quickly through an area. After the cold front passes, the weather is usually cooler and drier than before. And here, I'm going to have that picture in there for you. All right. A warm front occurs when a warm air mass moves over a slower cool air mass. Now, a warm front moves slowly and may take several days to leave an area. As a result, a warm front often brings several days of light rain or foggy weather. When a warm front passes, the following days may have warm, moist air. Go ahead and check out that picture. Sometimes air masses push against each other but do not move. They kind of like slam into each other and stop. Now, when that happens, the boundary is called a stationary front. A stationary front may stay in the same place for several days. All right, it usually causes cloudy skies and rainy conditions. Go ahead and check out that picture too. All right, page 119, we're talking about wind here at the top. Air varies in temperature. Many things, such as location, affect the air temperature and can make it warmer or cooler. For instance, air near the surface of the earth is warmer, but air at higher altitudes is cooler. Air is also warmer near the equator and cooler at the poles of the earth. Remember, the equator is the direct middle that goes right around the earth. If you look at a globe, you'll see a picture. There's a line around the globe that says equator. All right, cool. You can actually see it right here on this page, this guy right here. Look in the middle. There's a line straight through the middle of that globe that says equator. Now, equator, it's going to be warm because it's getting sunlight all the time. Now, the poles, the North Pole, South Pole, they're kind of at an angle each time, the sun's hitting them. Remember from that picture, I think it was yesterday, that picture yesterday that showed the sun hitting the earth. North Pole, not getting a lot of sunlight. South Pole, not getting a lot of sunlight. That's why they're super cold. All right, or at least direct sunlight. Here we go. Let's keep rolling. Changes in temperature cause wind, and warmer air rises. Cooler air moves towards the earth to replace the warmer rising air. These and other air patterns influence the movement of winds. All right, now global winds. This one's super big. The uneven heating of the earth causes global winds. Global winds move in large circular belts around the earth. Global winds include trade winds, the prevailing westerlies, and the polar easterlies. Winds are identified by the direction from which they blow. All right, the prevailing easterlies or trade winds blow from the east. So the east would be this side. So here's our east, here's our west. So the prevailing easterlies, also known as the trade winds, blow from the east towards the equator. Christopher Columbus used the prevailing easterlies when he sailed to the New World. These winds became known as the trade winds because trade ships relied on these strong winds to sail to the Americas. After trading their cargo, the ships would then return to Europe using the prevailing westerlies. So the westerlies are blowing from the west to the east, so that would push them from our country back to their country. In the northern hemisphere, these winds blow northward from the west. Near the North Pole and the South Pole, the polar easterlies blow from the east and move away from each pole. All right, so they're blowing from the east to the west. So they come out of the east. That's why they're named the easterlies. All right, sweet. All right, friends, that's all I had for you for science today. Hey, make sure you're still working on that science project. Get that Google slide presentation all squared away in the Google Classroom for science. Hey, once that's done, get it submitted, turned in to me, and then I'll be able to get that thing graded and get it back to you. Hope you guys have a great weekend. Enjoy a couple days of nothing. You get to do whatever you want, I guess, within your own house or backyard or front yard with your mask on. I don't know. Yeah, be safe, you guys. Keep washing those hands, and I'll check you guys out on Monday.